Welcome to the International Conference on Context-Aware Systems and Application 2021. This is Dr. Hafiz Mehfuzul Haq. I am currently working as an assistant professor in the Department of Software Engineering, the University of Lahore, Pakistan. First of all, I would like to thank to the organizing committee of ICASA 2021, especially the General Chair, Dr. Fan Kong Win, for having such a great conference where researchers from across the globe get a chance to present their emerging research ideas in the field of computer science, more specifically in context-aware systems and applications. I'm also grateful to the organizing committee of ICASA 2021 for giving me the honor to present as a keynote speaker. This year again, we are having online conference due to prolonged pandemic of COVID-19 and travel restrictions. We are very much hopeful that the upcoming year conference, ICASA 2022, will be held physically. The topic of my today's talk is contextual diffeasible reasoning formalism for heterogeneous knowledge sources. This is a joint work with my MS and PhD students. So as we see in the outline, we start our discussion with the core notion of context and context awareness and context-aware systems in progressive computing environment. Context-aware systems and applications are often run in a highly decentralized and heterogeneous environment, so there is a need to have a discussion on how context-aware systems can be modeled and reasons using different heterogeneous knowledge sources. Then we'll talk about contextual diffeasible reasoning formalisms to know how to deal with the inconsistency, how to deal with conflicting situations. Then we'll discuss briefly on context-aware e-health specialist and context-aware planner for cognitively impaired patients, and then we conclude this talk. So, recent years have witnessed the expeditious evolution of intelligent smart devices and autonomous software technologies with the expanded domain of computing, we can say from workplace to the smart computing environment in everyday routine life activities. As we see, due to that reason, the rapidly increasing dependency on these smart devices has made human life much more easier, comfortable, relaxed, and secure. In this arena, numerous smart devices are impeccably integrated via portable or sometimes they are embedded devices by providing readily available services to facilitate user at any time and anywhere. This trend has been rapidly advancing towards a new generation of the system where smart systems and applications play vital roles in acting intelligently on behalf of the users. So these users interact with the systems dynamically with or without human intervention using different modalities. Other way around, what we can say that these smart devices and applications are acting on behalf of the users. So everyday users spend much time and effort to accomplish their task and autonomously exchange information among different devices, among different platforms for their complex problem solvings. And they are trying to make their life easier, comfortable, and relaxed. On the another side, we can say human is becoming device dependent day by day. So as we see, we human beings are blessed with the ability of context awareness. What does it mean? Uh, Context awareness, like for example, we human, we have different kind of senses, like we can see, we can sense, we can smell, we can hear, we can touch. The same senses we are intending to provide to our smart machines. So now these smart machines are acting on behalf of the users by using these kind of senses. So we can say the emergence and penetration of smart devices and software technologies has a great influence on context-aware mobile computing research to use contextualized information for their daily routine life activities. As concerned with the core notion of context, literature highlighted many definitions of context in specifically in computer science domain. So in this talk, I specifically discussed two core notions of context that has been defined by that has been defined by people in different literatures. The first level that we see here, that is based on formal reasoning model for formal reasoning to model context-aware systems. And the second level that we can see here, based on multi-context system to model heterogeneous systems. So we will discuss in detail in the upcoming slide. So as we see, the first level definition, that is based on formal reasoning to model context-aware systems. So the well-known definition of context, the well-known definition that has been proposed by D and Abbott long ago, what is that? Context is any information that can be used to characterize the situation of an entity. An entity can be a person or place or any object, and they can have interconnection among themselves. So in context aware systems, we can say context awareness is the key characteristics of pervasive computing, which relies on the context having the capability of sensing the environmental situation by observing, by smelling, by realizing, or by touching. Anywhere we can have our smart sensors can have the ability to sense the environmental situation from the physical world or from a particular situation. For example, if there is a crowd on the road, so the smart sensors can detect the crowd on the road. So either what kind of situation our smart sensors detect, they grab the situation, they trace the objects and users' behaviors, what they are doing, then they take intelligent decisions based on current evidence, current information what they have, and they act according to the environment. Just like we human beings, so sometimes, for example, we plan to have a specific task. So what we do, we get the information from the environment, from other person, from other object, and then based on that, based on the existing information, we take specific action. The same thing our smart devices intend to do here. So contextual definition has been classified in different forms. For example, as we see in the diagram, context, we can have different kind of context. We can see user context, device context, physical context. So when we talk about specifically the user context, here we can say the user identity or activity of the user, or we can say the preferences of the user. So these are specific objects of user context itself. They are classified as contextual information. When we talk about device context, so we can see, for example, device name, device speed, device specification, device quality. These are device contextual information. When we talk about physical environmental context, in the physical environmental context, we can see, for example, in the room environment, we can have a light, we can have fans, AC, air con, or we can have humidity sensors. So these are the smart sensors uh, that can be modeled using contextual reasoning process. For example, just from the computer system, we can switch on the light or switch off the light, or just the motion detection camera can detect there is somebody in the room, so light and fans should be automatically on. How this could be done? The system realizes the contextual information specifically in specific environment. So we can have resource contexts like different kinds of resources, type of context, size of context, resources. Then we can say network. Network context can be defined in terms of network bandwidth, network speeds. Location context can be defined in terms of location object, location of a specific person, or when we talk about temporal context, so time of specific activity, starting time, ending time, or at any time of the day should be considered as temporal context. So context aware systems as a whole, we can say context aware systems acquire contextual information from the sensors, embedded sensors in smart devices and information systems, and then perform reasoning and then adapt behavior accordingly. So as we see in the environment, we can have different kind of devices, different kind of systems and applications, smart systems and application. For example, in smartphone, so smartphone can have different kind of sensors that are embedded in the smartphones. So based on that, these smart sensors acquire the information. For example, GPS systems collect the information. So this is embedded sensors in our smartphone. So context-aware systems are often run on tiny resource-bounded devices. As for example, we can say we can have very small sensors that are embedded in our smartphones. So these sensors often interact with the human users. They exhibit complex adaptive behavior, and they usually run in a highly decentralized environment. Mobile phones have gained significant attention due to its integration of context-aware computing, having the capability of perceiving or sensing the physical environment. They are able to adapt and react to the dynamic changes of the environmental situation in order to process the given scenarios. So as we see here, context aware, when we talk about specifically, when we talk about context aware sensors, so these sensors just provide the information after certain intervals of time or continuously. So when these devices, the task of the sensor is just to provide the information. So what we need to do, we can model these sensory information using context aware agents. So when we design this sensory information using context-aware agents, so we can say context-aware agents are autonomous and proactive, which have belief about the world to realize the situation and act accordingly. How? For example, there is for example, you can say light is on. So the light sensor is detecting the light is on. That information is available. That information is the input of the light agent. Light agent, when this information realize that this information, the light is on, so light should be off when there is nobody in the room, right? So the context aware light agent will detect after certain intervals of time if there is no movement and there is no body, there is no one in the room, so light should be automatically turned off. So in this way, we can say that context aware agents are autonomous, they are proactive, having belief about the world, what action should be taken. So these smart devices and agents use various reasoning techniques to develop context aware systems. So when we talk about context aware reasoning, so we can say contextual reasoning play a vital role in the domain of context-aware systems and application to infer the contextualized information from existing knowledge sources. For example, we can have the environment, university environment. So the existing system is the university environment. So the sensors detect specific information from that environment, and then based on that information, they perform reasoning and act according to the environment. So if this environment changed to some other environment, definitely our systems are intelligent enough to detect and to analyze the situation and act according to the different environment. This system take decisions intelligently and interactively in the real-time environment. So Chen and Tolia, they define context aware agents, as for example he mentioned, we humans are inherently context aware agents. Like the human, we can think, we can see, we can sense, we can change the mind based on current observation. The same thing current context aware agents can do. So as a result, when these smart devices runs in a highly decentralized environment using tiny resource bounded devices, so we need to ensure the system's correctness properties in terms of response time, communication, and system's proper termination process. In addition, the system also need to ensure the system's qualitative as well as quantitative properties of the systems. So contextualizing heterogeneous knowledge sources, now we are moving towards second notion of context, that is based on multi-context systems to model heterogeneous systems. So context-aware systems and applications have gained significant attention in mobile and pervasive computing paradigms to model heterogeneous knowledge sources. As I discussed earlier, context-aware systems and applications are often run in a highly decentralized environment. That's why we need to focus on different heterogeneous domains. So in real context-aware deployment setting, a coalition of heterogeneous domains often require to mutually exchange or share contextual information while preserving the identity and independence of each specialized domains. For example, this is a practical scenario as we can see here. When we talk about specialized domains, so let's take an example of university management system, hospital management systems, and third partner we can say insurance company. So university management system, it has its own set of criteria. For example, university enrollment system, university student management systems, and they can have their staff management system, etc., library management systems. And when we talk about hospitals, so in the hospital we can have, for example, patient care systems, doctor management systems, etc., these kind of systems here. When we talk or specifically discuss on the insurance company, they can have their own set of plans and activities to execute their systems. So as we see, there are three partners like university, hospital, and insurance company. So they are among themselves interacting. How? For example, a university employee, he or she might have to take some medicine or need some medical assistance from the hospital. So a university employee visit to hospital. So hospital in the hospital, when he is diagnosed by the doctor, that fee is paid by his insurance company. So what we can say here, university, hospital, and insurance company, they are standalone bodies. They are having their own identity and they are working individually their own independent works. But when we talk about the insurance of the employee of the university, so at that time we can say that three contexts, for example, three different domains are interacting among themselves based on common communication mechanisms, or we can say agreed plan. For example, a university employee will get insurance from the insurance company, and that insurance company will pay to hospital on behalf of the patient. So this is a triangle that we can see here. So considering these three domains, university, hospital, and insurance company, we consider each domain as a single context. So we will discuss a bit details in the next slide. So this needs different modeling approaches to share, exchange heterogeneous contextual information considering more than one domain using the notion of multi-context system, distributed description logic, and multiple ontologies. So the notion of multi-context system has been used for interlinking different knowledge sources in order to enhance the expressive capabilities of heterogeneous systems. As I mentioned earlier, like the university, hospital, and insurance company. These are three standalone bodies. How they interconnect, how they interlink different contextual information using the notion of multi-context systems. It could be one of the solution. So a multi-context system includes a set of context and a set of inference rules that allows information to flow among different contexts. So in multi-context system, each context is defined as a self-contained knowledge source, which includes a set of axioms and inference rules to model the systems and perform reasoning. So there is another approach, we call it distributed description logic. Basically, description logic is also a formal representation to model a complete domain. So this can be represented in the logical format, in the logical pattern. So we can say that distributed description logic is a formal logical framework which combines different description logics knowledge bases to express heterogeneous information. So DDL is specifically designed to formalize multiple ontologies interconnected by semantic mappings. Here we use the term multiple ontologies. Why? Because when we talk about context modeling, so in context modeling we can have different approaches. In context aware computing, people have specified different context modeling approaches. For example, key value markup scheme models, logic based modeling, object oriented modeling, and ontology based modeling. Among others, ontology-based context modeling approach has been advocated as one of the most promising approach due to its modular structuring mechanism and its very good feature of reusability and independence of its own identity. So when we design ontology for each individualized domain, for example, for hospital we can have different domain, different ontology. University we can have different ontology, and for insurance company we can have different ontology. On the top of that, what we do, we develop description logic knowledge base. Why we need to develop this one? Because description logic is the what we can say the ontology axioms can be transformed to description logic, and description logic is a subset of first order logic. And first order logic, as we know, this is human understandable language. So we can say that semantic knowledge, in this way, semantic knowledge can be transformed into natural language, or we can say human understandable form. So in this work specifically, when we talk about this work, so we can say that contextual data and all informations of specific domain are stored in one ontology. Another domain ontology, another domain information can be stored in another ontology. On the top of that, we can have description logic. On the top of that, we can have first order logic. In the first order logic, we can write simple predicates and relationship that can be further programmed using any programming language. So the question arises here, how these different ontologies and different description logics can be combined. It can be combined using bridge rules. Bridge rule is an inter-ontology axiom that allows the concepts of ontology to subsume the concepts and rules from another ontology. So in that way, using bridge rules, we can say that we can interconnect different ontological informations. So this is we already have discussed all these details here. So now we need to see, when we model this domain in the ontology, and when we are modeling there, we need to write some complex rules for that domain. For example, how the system for their like we need to model the domain and their complete inference systems. So specifically, when we talk about inference systems, so we need to see how context-aware systems can perform reasoning. So as I mentioned earlier, that contextual reasoning plays vital role in the domain of context-aware systems to infer the contextualized information using existing knowledge sources to take decisions intelligently. So when we say using existing knowledge, so we can say how the system perform reasoning. So in general, we can have two types of reasoning. We call it monotonic reasoning and non-monotonic reasoning. Monotonic reasoning is very simple. That are these kind of reasoning are interpreted in a classical pattern. For example, this we can have specified rules that are interpreted in a classical way. When we talk about a non-monotonic reasoning, so once you prove something is true, it can be negated based on contrary evidence. So non-monotonic reasoning specifically designed to provide the conflicting situation that non-monotonic reasoning is basically provided to show how we can deal with the conflicting information or contradictory information. For example, a patient situation at the moment is very serious. So just after 5 minutes, again, we have to see the patient scenario. Might be it become more serious, or might be possible that it becomes less serious. So how this could be done? This kind of reasoning that rapidly changing. So this could be done using non-monotonic reasoning. So diffeasible reasoning has been considered as one of the most successful sub-area of non-monotonic reasoning to deal with inconsistent and incomplete information due to low computational complexity and its focus on implementability. This is the major reason of choosing diffeasible reasoning here. So in non-monotonic reasoning, we can have different kind of reasoning. For example, default reasoning and many other reasoning mechanism there. But we opted diffeasible reasoning here just because of its low computational complexity and its focus on implementability. In addition, it provides contextualized information to model heterogeneous systems. It provides the facility on that. So it is a simple rule-based technique that supports priorities among the rules to resolve conflicts here. So we can see CDL, like in contextual diffeasible reasoning, or we call it CDL, it consists of a set of rules like strict rules and diffeasible rules and defeater rules, right? So we can have set of strict rules and diffeasible rules. These are interpreted, or we call it, they perform reasoning locally. Locally means, what does it mean? For example, if diffeasible reasoning applied at hospital systems, so they can have their strict rules for their classical interpretations, and they can have diffeasible rules for their to deal with the how to deal with the conflicting information. But in the same pattern, these diffeasible reasoning can be applied to insurance company and the university systems. But the thing here, if these three standalone bodies would like to connect among themselves, how they can, using mapping rules. So diffeasible reasoning provide mapping rules that are constructed to model heterogeneous knowledge sources. So using that, mapping rules provide association of local contextual information with foreign contextual information. That means at one end we can have for example, the university system, they can have their own mapping rules, but they incorporate insurance company and hospital within their mapping rules. So they come up with the agreed plan. So in the next slide, we talk about specifically the work that is context aware health, e-health specialist. So basically, the core intention of developing this work is to help elderly people or the patients who are bedridden. So we propose a context-aware multi-agent reasoning-based health formalism to monitor the patient's vital sign parameter using Raspberry Pi. So the proposed formalism consists of different smart devices embedded with the sensors that can use contextual information that are acquired from different sensors, for example, ECG sensor, body temperature sensor, and heart rate sensors, and that sensory information are transformed to agents, their corresponding agents. That agents get the value, this perform reasoning based on existing information, and then if there is something abnormal, they forward this information to the patient care agent, so that patient care agent take this in, whether there is emergency situation or less emergency situation, or there is normal situation. Based on that systems, the patient care systems respond accordingly. So this formalism basically consists of two layers, or we can say there are two folds of the application. One is agents modeling and reasoning, and the other one is application layer. So in the agents modeling and reasoning, we can say that we can just model the system, how agents acquire information from the sensors, and after certain intervals of time perform reasoning and generate alert notifications. In the second fold of the application, that is application layer, so we present the prototypal implementation using a comprehensive case study and provide the validity and we shows the validity and correctness of the proposed systems. As we see in the next diagram, the architecture of the proposed system, as we see the patient's body, different sensors are attached to the patients, and these sensory information are stored in the form of facts in the knowledge base of the Raspberry Pi. So Raspberry Pi basically a smart credit card size chip that act as a computer that basically using that we can model different sensory informations. So that information is further converted into rules, and that information further stored on the server, and the server respond to different heterogeneous environment, for example workforce, caretakers, and doctors wherever they are in the environment. So this is the case study that we can see here, the Raspberry Pi. So Raspberry Pi, as we see the patient who is on the bed, and sensors are attached to the patient, and that sensors sense raw information. What we can say, that sensor provide information into the Arduino in analog form. So why we need to use here Arduino? Because that get the value from the sensors in analog pattern. Then Arduino is connected with the Raspberry Pi because it can convert the information to the to Raspberry Pi, and Raspberry Pi deal with the information in digital pattern. So we can say once data is acquired from the sensor, it is transmitted to Arduino board in analog form, and then it converts to the digital formats. So as we see in the diagram, we can have MQTT protocol, we can have InfluxDB and Grafana. So the core purpose of using them, MQTT broker basically is an open source application software. So it can be used, it is basically installed on the Raspberry Pi first, and then it can be used to transfer data to InfluxDB. And InfluxDB basically is a time series and open source database. When Grafana is while we can say the Grafana is a general purpose open source dashboard that or we can say a graph composer that is used to represent the outcomes of these sensory informations. So as we can see here, in the device, we can see here, for example, there is this is a prototypal implementation. At the beginning, we can say there is no the line is straight of ECG because the sensors are not attached to the patient. When these are attached, so you can see the ups and down lines, and here we can see the output in using Grafana. So we also tested this case study on different groups and of different ages. So we can say the first group with the age of 25 to 40, the second group with the age of 46 to 80, that is male, and the second group is 46 to 80 is the same with the females, and the third group that is with the stress employees. And then we can see here we also tested it for the children and teenagers. So we can see, as we see in the table, heart rate sensors, we are getting heart rate manual sensors, manual information, and the variation rate. In a similar pattern, we can see body temperature sensors and body temperature manual value and variation rate. So we can see here the first value, that is 103, and using sensors. The second one is 111, that is using the manually, that is obtained manually. So the variation rate is 0.08. So in the same pattern, we can see body temperature sensor detected the temperature at 98 degrees Celsius. So manually it is known as 98.6. So there is a 0.06 variations. So as we can see, the variation rate here 0.03, 0.04, 0.04 and 0.07 for different class of groups, and the same variation we can see here in this one. So the graph of the heart rate and temperature is given below. So the next work is on context-aware planner for cognitively impaired patients. This work basically specifically designed for the cognitively impaired patients who usually forgets to usually forgets their daily routine life activities. For example, a patient who has to take medicine at 8 p.m. in the evening, but he or she often forgets. So this is a sort of auto reminder systems that will remind the person to take specific action at specific time whenever needed. So this case study has been designed for the people who normally face difficulty in reaching their activity on daily basis. The system would assist the patients in planning and managing their routine life activities. So this formalism consists of basically three layers. There is sensors layer, semantic layer, and reasoning layer. So this on this sensor layer, in the sensor layer, we can have different sensors that are embedded in the smartphone of the user, and we can have some other sensors that are connected using a smartphone or smart device. So that sensor provide information. We assume this sensor provide the raw information to context aware agents that can be modeled in the ontology. So when we model the ontology in the semantic layer, so what should be done here? Initially, we completely model this domain in the ontology. Then after that, we test this case study using Hermit reasoner to check the consistency and correctness of the systems. Later on, we executed SparkQL queries to test whether whether the user's activities are fulfilling according to the requirements or not. In the reasoning layer, context-aware agents uh, collaboratively plan activities to infer the desired results and notify the patients to take appropriate actions accordingly. So we can say in general, the system consists of context-aware agents like social agent, food agent, medical agents, or we can say exercise agent, that different agents that remind the person what action should be taken. For example, there is exercise time, so auto reminder system, this planner will remind the person, now this is the exercise time, so you should proceed with the exercise. So as we can see in this table, a person is a Bob. We have considered a case study of the person Bob who planned his activities on every Sunday morning. So on each Sunday, he planned the activities of all week. So on one Sunday, he planned all his activities like wedding ceremony, TV serial, birthday party, tour, cricket match, and tour on different days and timings, etc. So sometime what happened? Sometime an activity might be changed, or activity time might be changed, or activity might be cancelled, or sometime there is a chance a new activity should be added, or sometime there is a possibility that one activity should be replaced with another one. So how it could be done? It can be done using contextual refeasible reasoning. In contextual diffeasible reasoning, we have the option of priority. So using that, we can set and prioritize the task. One thing important to mention here, expected travel time. Basically, when Bob has different activities at different locations, so it might be possible that different activities are on different locations. So there is a need to check the expected travel time from one activity. For example, one activity that is ending at 10 a.m. So the next activity should start at 10:30. So we need to calculate the distance from activity that is ending at 10 and new activity that is starting at 10:30. So we need to calculate the total distance. If there is more than that distance, for example 40 minutes, let's say, so in that case Bob should get a reminder to reschedule this activity because the travel time is more than that. So to test this complete plan, we executed different queries based on Bob's plan, replan, and rescheduled activities. So in total, we executed 50 queries. So the number of correctly answered queries as per Bob's plan, that are 39, and the not working queries, that means the Bob tried to get his schedule, but 8 times the system did not responded well, and the number of incorrect queries, that 3 times. What happened, Bob requested to the planner to query his schedule, but the system did not respond. So at this moment we can see the accuracy and precision of the system, that is 82%, and recall rate is 78%, and F Meyer is 80%. At the moment, we tested this case study using colored patronets, right? So we model this case study of cognitively impaired patients in colored patronets to analyze the behavior of the system and validate the correctness properties. So colored patronet basically a graphical modeling language that is a union of patronets and functional programming language. So colored patronet, or sometimes we call it CPN, it can be used to model the simulated and verified model domains. We can model the domains to simulate the behavior and verify the system's execution pattern. We need to explore, we need to analyze the state space and invariant analysis. CPN also allows the properties such as absence of deadlock, or we can see in the CPN model we can have different sets like transitions. We can have different of tokens when tokens are assigned to the persons or specific activity. So as we see in the diagram, on the top of that we can have 3 core activities. So we can say that when we formally model check and verify the correctness properties of the system, so for this we initially model the user's activities in this plan. So when we set this plan, so as we can see in the syntactic representation as shown in the diagram, user places a total of 4 tokens which corresponds to their 4 activities, like we can say for example exercise activity, or we can say entertainment activity and social activity. Entertainment, act means exercise activity, and S represent the social activities. So we can see at token 1 we can have 1 exercise activity. We can see in this week the person Bob having 2 social activities and 1 entertainment activity. So this is a planner that generate his plan as per token according to the priority level. So as the user receives the activity request from as the system receives the activity request from the user, so as user chooses the corresponding contextual agent plan activities. Then users also sometimes there is a need to communicate with different agents. So for that purpose, user agent uses special communication primitives, as we can see here, tell by ext2a, or we can say ask to exercise agent a. So these are the communication primitives to exchange the contextual information among different agents, and firing rule of instances and the system transitions. So in this slide we can see the system correctness properties. So to validate the CPN model, or we can say CPN multi-agent communication model, we use state space tool to analyze the behavior and correctness properties such as boundedness, liveness, and fairness properties. So as we see in these states, a total number of 3,645 nodes that have been visited during these transitions, and 12,312 arcs that we can see. So it is strongly connect. These systems are can have these systems are connected with the strong connected graphs. So as we see in the diagram, like we can see verification of liveness properties implies the absence of deadlock. As we can see the dead marking at diagram C here, 3645, and boundedness in the model checking is also used to find the bugs in the system designs. So we also verified the systems using to check the validity of the systems, and we realized that the systems that Bob planned to generate for the whole week, so it is working as per guidelines. So we conclude this talk. So in this talk, basically we discuss how context-aware systems can be modeled in heterogeneous environment, and how to face different kind of challenges and how these challenges can be modeled. So these challenges in heterogeneous environment, for example, the imperfect nature of context that can cause inconsistency, incompleteness, and contradictory information, conflicting information that we can see. So there could be one solution that we can say using bridge rules or mapping rules that can be interpreted using contextual diffeasible reasoning. As I mentioned earlier, in non-monotonic reasoning, it is advocated as one of the most promising languages due to its low computational complexity. And it's easier. It's a simple rule-based reasoning technique that is more efficient than other techniques. So considering that it has low computational complexity, so that is easier to implement in the heterogeneous environment. So this is the end of my today's talk. This is the time for question and answer session. I may be contacted at the following email addresses if needed. That's all from my side. Thank you very much. At the end, I would like to thank to the organizing committee once again for providing me the opportunity of this talk. Hope to see you in the upcoming conference physically. Thank you very much.
Hello everyone, we are a research team from Thương University. We would like to present our study about Vietnamese export growth prediction applying MIDAT and MFRA on mid-frequency data. First, I would like to tell you about why we are interested in this topic, and then we're going to be showing you how we managed to investigate the potential research. And finally, I will show you the result indicates that our research methods are on the right track. Let's start with the introduction. We all know that trade is a key component of GDP for almost any country. That is particularly true for an export-oriented economy like Vietnam. According to trade report, Vietnam's situation of export and import can face uncertainties from many domestic and international factors. Therefore, an accurate forecast of export growth will help policymakers build national economic growth scenarios, as well as help countries be more proactive in their foreign exchange reserve. For any macroeconomic forecast, there is a need to have the most precise and most timely estimate possible. This growth that have a common challenge from macroeconomic data when report contain data with different frequency. They are not officially made available at the same time, or in many cases, they can be lagged in reporting. Because of this reason, our aim is to apply mid-frequency data model on forecasting export growth in Vietnam. The forecasting macroeconomic indicator in general and export in particular are very interested and studied by many researchers. From the perspective of international trade, many export forecasting models approach from classical to modern theory, such as the gravity model, export demand model, Bayesian regression model, and the machine learning method. But most of the study use the data with the same frequency. The characteristics of macroeconomic indicators are that they are often public with different frequency. Some are public annually, but others are public quarterly, monthly, or daily. In addition to that, macroeconomic indicators often have different public time, making it difficult to employ data for forecasting predicting. To deal with the issue, one of the macroeconomic forecasting methods in recent years which has been studied and applied by many scientists around the world is a model with variables collected and published with different frequency, such as the mixed data sampling model, the breeder equation, and the mixed frequency VRA model. At the same time, study in Vietnam had hardly mentioned the model of using data with mixed frequency in forecasting macroeconomic variable. To the best of our knowledge, no other researcher has previously managed to find evidence of using mixed frequency model for export forecasting. Therefore, this study investigates the performance of models that work on mixed frequency data for export forecasting problem. In the next slide, I will be showing you some fascinating data we use in our research, and later on we can see how it works in practical. This research is carried out on a dataset of macroeconomic indicators we collected from the website of General Statistics of Vietnam, from the website of IMF, from the website of World Bank, or from the website of ADB, even Bloomberg website. Basically, we selected 19 economic indicators with 22 variables, of which we have 5 quarterly frequency economic indicators, and we have 14 monthly frequency variables, and please pay attention as the last 3 variables, including monthly exchange rate, the future contract of gold, and the future contract of oil. Those 3 variables also have a weekly frequency, which we call is a financial variable. And after collecting and pre-processing, the dataset was divided into 2 datasets of 2 different states, in which the dataset in the period of 2006 to 2018 is used to estimate the parameter in the regression model, and we call it the training data. And the dataset from 2019 to 2020 is used to forecast. We call it the testing data. One problem we are facing is the missing data issue. There are 3 variables have missing data at the end of the research period, including money supply growth, reserve ratio, we missing for the whole year in 2020, and total international reserve including gold missing data at the last quarter of 2020. And the ARIMA model is one of the most effective short-term forecasting model for macroeconomic indicator. Therefore, in this study, we apply the ARIMA model to predict for three variables with the missing data. The method we are using is a required as follows. We use two methods. The first method is a mid-frequency VAS model, and the second method is a MIDAS model. We don't have time to look at the complete process, so I just want to show you this part. If you are interested in the whole process, then I can explain it as a question and answer section, or you can look at it up on our paper. The MF-VAR model is a VAR model that analyzes time series data with the mid-frequency. This model is based on the state-space approach and was proposed by Mariani and Murasawa in 2010. In this model, to process data with different frequency, the variable with low frequency is considered as a high-frequency variable with missing observation. Then, the low frequency variable will be applied technical to transform to the same frequency of the highest frequency variable in the model. The MFVAR usually has many parameters that are estimated by two following methods. The first method we can see on the screen is based on the classical approach to estimate by using the maximum likelihood technique. While the second method is to use Bayesian inference with the expectation maximization algorithm. It means that simply explain, if we would like to estimate YTM from the ETM, we cannot estimate it directly, but we have to estimate YTM through the YTM star. And from YTM star, we will estimate it through ETM star. Whether in this equation ETM and YTM star are variable with a high frequency, and UTM is a random error with zero expectation and constant variance. The second method we use to compare, actually we use two methods to make the comparison, the result, to make the comparison between the method. The second method is the basic MIDAS model for a single explanatory variable, as we can see on the screen, in which we pay attention to some index like YTQ is a dependent variable with low frequency quarterly, and XTM is an explanatory variable with high frequency monthly. Other index is a TQ is a time index, and TM is a time index with a higher frequency. Another index we need to pay attention is the M. M is the index to define a higher degree of frequency of the independent variables than the dependent variable. For example, if Y had a quarterly frequency and X had a monthly frequency, then M equal to 3 because on quarter we have a 3 month. And if Y had a quarterly frequency and X had a weekly frequency, it means that we have a 3 month and 4 week. It means then M equal to 12. And the other index we need to concern is the BLM theta, CK theta, and the coefficient of the regression model is beta 0 and beta 1. Okay, so that covers the methodology, and now I am going to outline our result. I'm going to give you the most important finding of our research. Initially expected, we start with three models. There are some economic indicators at varying frequency are included in the data collection. As a result, in order to develop the optimal model for predicting export growth, we examine the MFVAR model using three scenarios in which the data of some economic indicator change with increasing frequency. And we can see in the screen that we have a three model. The first model we include the 5-quarter frequency and 11 monthly frequency variable. The model 2 we include 2-quarter frequency variable and 14-monthly frequency variable. The difference from model 1 is that the 3-quarterly frequency variable has been replaced by 3-monthly frequency variable, including gold, USD price, and oil price. So the variable is a financial variable. And the last model, including 2-quarterly frequency variable, 11-monthly frequency variable, and 3-weekly frequency variable. Now, let's look at the first result of the MFVAR model. The column in the red line is the real value of the export growth, and the blue line is the estimated result. To compare the prediction result of the three models, we can see that the accuracy or error of the result must be measured. And currently, MAE mean absolute and RMSE root mean square are regarded as two excellent predictive accuracy measurements that are commonly applied in many studies. And in this study, we also examine the predicted accuracy of three models using two criteria in this study. And the result also seem to indicate that, as we can see in the red line at the bottom of the screen, that the average error of the three models are, according to MAE standard, is greater than 7. And the figure 2 shows that model 1 is the orange line delivers the closest predicted result to the true data series blue line across the whole period, and with the semantic RMSE and MAE error value among the three models. And the model 3 red line simulates the trend better, but the gap between the model 3 forecast point and the original data is very large. Model 1 and Model 2 forecast value are almost ineffectual from 2012 outward because export growth change regularly with a significant margin. And Model 3 amplitude fluctuates far beyond the actual value. As can be observed, the MFVAR model is not suitable for forecasting Vietnam export growth over the research period using the given collection of macroeconomic data. Let's see at the second result. We use the same model. We also develop three models with the same variable, with the same frequency of each model. And also the red line is the real value. And in this case, the blue line we concern is an absolute error. The three proposed model provide a good forecast of Vietnam quarterly export growth, particularly in the fourth quarter of the 2019. We can see in the screen. The MAE of all three models are mostly smaller than the fourth quarter of 2020. In 2019, Model 1 and Model 3 quarter. Model 1 had 3 quarters, and Model 2 and 3 had 4 own quarters with forecast error smaller than average absolute error MAE, while the fourth quarter of 2020 mostly had error bigger than MAE. So from this result, we can see that the finding demonstrates that the MIDAS model is superior in short-term forecasting. The forecast error according to two criteria MAE and RMSE1 again shows that MIDAS 2 and MIDAS 3 model predict export growth of Vietnam better than MIDAS 1 model. And the forecast result of two models, Model 1 and Model 3, is almost equally good. This is due to the fact that MIDAS 2 and MIDAS 3 model use more variable with a higher frequency data than original model. And from the figure 3 indicates that when we compare to the actual data series, the three MIDAS model accurately anticipates the variation chain of Vietnam export growth trend. Most of the time, anticipated export growth follows real export growth with only a few exceptions, such as the period of 2006 to mid of 2007 and the first 2 quarters of 2014 and 2015. Furthermore, the forecasted outcome closely checks the export cycle peak and trough when comparing the prediction line of the MIDAT-2 and MIDAT-3 model. It is clear that the two models provide very comparable forecast results. So from this result, we believe that our result also highlights that the development of the forecasting model is on track and the input data is suitably chosen. Furthermore, adding high-frequency financial data to the MIDAT regression model also enhance prediction accuracy, demonstrating that financial data had an important role to play in predicting export growth. The finding implies that in order to fully utilize the forecasting ability of financial indicator, they must be combined with macroeconomic data. For the conclusion and the future work, and now we sum up brief. The study used the MFRA and MIDAT model to anticipate Vietnam export growth from 2006 to 2020 using a data collection of very frequency economic indicator. The analysis results shows that the MFRA model had high forecasting error and is not suitable for forecasting the export growth of Vietnam, whereas the MIDAT model produced good forecast results using the same dataset. Furthermore, as with several previously published study findings, the forecast results suggest that the MIDAT model is effective for short-term forecasting, and the finding also suggest that high-frequency financial variable can be used to forecast Vietnam export growth. This would be linked to the recent development of Vietnam financial market. A possible limitation of our work is that gathering data for the study is still difficult, but as we hope we have highlighted, we are still only in the first phase, so we are more interested in the methodology, but in the next phase, we are planning to implement the data using higher frequency such as weekly or daily, and we continue to build and deploy models with varying frequency data to anticipate the other macroeconomic indicators. So thank you so much for your listening.
Hi everybody, my name is Eai. Now we continue with my paper. The title of this paper is Improving Morphologies and Recurrent Residual Refinement Network to Classify Hypertension in Retinal Visual Image. My presentation includes 6 sessions. The first session is Introductions. The second session is Background and the Relays. The third session is our proposed methods. The first session is Experiment and our result. The next is our conclusion. And the final session, that is some reference. And now we start with the first session of presentation. This is the introductions about project. The hypertension classification based on the retinal blood visual segmentation is one of the state-of-the-art approaches. In this slide, we can see that there are some retinal blood vessel images. They have many information of disease, such as hypertension, heart disease, diabetes, etc. The final image that is the result of segmentation. From these results, the blood had a thing from 1 to 9 pixels. With everybody, this is very small. However, with disease stratification, this is very important. Therefore, the detection and classification of hypertensive retinal image is very useful in the diagnostic of doctor. In this paper, we propose a new method for the hypertension classification based on the saliency. The saliency is the basic concept for choosing the strong area of objects in image, not only based on superficial. Many methods were proposed to classify. We can start with the trend form. This trend form has 2 periods, decomposition and reversion. In the decomposition, from the input image, divide the multi-level, and each level is applied the filters or the thresholds, such as Laplacian filters or direct filter bank. This is the result for the calculating of the covariance or the parameter for the reversion. However, trend forms have many disadvantages. The first disadvantage, such as the adapting with many filters or thresholds. This is my class information. And the second disadvantage, that is the time for processing environment. Another method is morphologies, that is based on the mathematics or based on the step or the value of the neighbor pixel. In the recent years, the development of machine learning, of neural network, or deep learning, such as convolutional neural network, fully convolutional network, UNet, or something like that. On the other hand, the connection between physics inference system are the basic of the silent map for the deep learning. The silent map is a concept based on the superpixel. From the research, we can rule that the limitation in prediction because of the input parameter and the output layer. From the input, noise and blur value that is creates the decreased quality of the input image. In some research, the actual tester for the saliency classification can be divided into multi-level encoder. We can call that the convolutional layer. The high-level receptive fields are the semantic information, such as its part in object, color channel, ray level in surface, and something like that. The low-level features can be adjusted as corner, orientation, The figure 1 is a popular deep learning for the silency prediction for the classification. We can see that from the input image. A popular learning model can be include 3 periods: downsampling, upsampling, the multi-output. From the input image, multi-level apply convolutional layers, and that is the input for the deconvolution in the upsampling period, and continue to the input for the silency prediction of the final period. The synthesis of all silency predictions of the final period, that is the silency combination for the classification. Based on this knowledge, we propose a new method for hypertension classification. Our methods include 3 stages. From the input is the retinal blood visual image. The first stage is the morphology. The second stage is the recurrent residual refinement network. And the final stage that is the silency classification. In this model, morphology stage and recurrent residual refinement network are the main stage. The original morphology stage includes 7 steps. A figure 3. From the input image, the first step is choosing the channel color. Each image has 3 channel colors, that is red, green, and blue. In this paper, we show green channels for the next step. In the second step is the CLASE, that is the summary of the contrast limited adaptive histogram visualization. The third step is the top hash transform. The next is the applying the filter. Next, binary transfers. Next is the enhancing the quality. And the final step of the morphology stage is the applying mask. This is the referring for the segmentation. However, in our model, we only use the result of steps from 1 to 9 in the original morphology methods. The adaptations of our model for silency map based on the residual refinement block. And in this model, he chose steps for the residual refinement block. From the input, we use upsample for low level and high level. Low level has 2 information. The first information is the silency map, and the second is the input for the 3 blocks of convolutional and ReLU. The final result combination with the silent map, that is the input for the second step. And the second step is similar with the structure of the first step. The silent map and the other result of the high level, that is the input for the 3 block convolutional and ReLU. And the synthesis that's on, that is the silency classification for hypertension classification. That's on the step in our model. We test in 2 datasets, either stage and right. Our datasets has 2 classes, hypertension and non-hypertension class. As a result, the final stage gives the classification about the kinds of disease in retinal blood vessel. And that is the result of the original morphology stage with 7 steps. From left to right, the first figure is the original image input. Next is the result of the showing the green channel for the next step. Next is the result of the CLASE step. Next is the result of the top hash transform. Next is the result of the applied filter for the step, and in here we apply the Gaussian filter. Next is the result of the mean C threshold step, and the final is the result of the denoising step that is preparing for the final segmentation. We compare the hypertension classification based on the accuracy of prediction and classification. The table 1 presents the evaluation of the morphology method and some deep learning model, such as convolutional neural network, fully convolutional network for the silency classification in all datasets. We can see that the combination of the morphology method with our recurrent residual refinement network is better than others. In this table, the second column is the morphology methods, and we apply the original method with the 7 steps in the figure 3. The next column, that is the result of the morphology combined with convolutional neural network in 6 blocks. And the next column is the result of the morphologies combined with 6 blocks of the fully convolutional network method. And the final column, that is the result of the morphology and recurrence residual refinement network. That is our model. And we can see that the ROPO method fits with the hypertension classification. The next table, that is the evaluation of the average success index in ratios of filter step with the ROPO method. The table 2 presents the average success index. The second column, that is the morphology for segmentation. We apply the algorithm with a 7 step in the figure 3 for segmentation to evaluate clearly with the silency for the classification. The third column is the result of the morphology combined with our models in testing. Into approaching the success index based on the mean C resorting for segmentation is higher than Bayesian, median, or the Gaussian filter. So we apply mean C resource for the evaluation with our model for silency, and we compare the results of our method with the recent method. In here we combine with three methods. That is the first method that we compare is the recurrent residual refinement network for the silency classification. In the reference with the numbers is 15. The second method for the computation, that is the morphologies based on the feature extraction, that is the reference in the number of 17. And the final method for the comparison, that is the morphology and superpixel based on fast fuzzy semis clustering network for the silency in the reference of 20. And the final comparison, that is presented clearly in the table 3. From this value, we can see that using the morphology for the inputs of deep learning gives a better result for the classification system. However, depending on the filters or the result for choosing the number of the inputs parameter, that is also a vital step. The results of the ROPO method are better than the others. In this paper, we ROPO a new method to improve the morphologies with a deep learning for the hypertensive classification in retinal versus image. And I think that the nature of improving the quality and choosing the color channel for transform overcome the limitation of the noise detail in the learning model. So the detection and classification, that is the very important for the diagnostic of the hypertension. And we can conclude that the improving the quality and choosing the color channel for the input parameter, that is the necessary. The morphology is an own approach in image segmentation. However, if it becomes one of the parameters of saliency classification and determining, the result will be better. We compare with the recent order, and we can see that our experiment results are better than others in the states and the right datasets. In the future, we want to improve the results of our model and test in other datasets. Okay, we have just go through an important point of my work. That's all, and this is some reference that we use in our research. Yes, and thank you for your listening.
Hello everyone, my name is Thành. I come from Ho Chi Minh City Open University, Vietnam. Today I read a paper entitled The Impact of the Contextual Substitution in Vietnamese Marotech Augmentation. My presentation has 5 sessions. Session 1 Introduction will introduce the context of our problems. Session 2 Related work. Session 3 presents our approach to generate new training data from the limited training data based on the contextual substitution. Session 4 The experiments. We perform several experiments to evaluate the impact of the contextual substitution approach. The final session is our conclusion for this paper. Session 1 Introduction. As you know, the annotated dataset is an essential requirement to build an artificial intelligence system effectively. The abundance of annotated datasets will help to enhance the generalization of the predictive models and avoid overfitting. However, the annotated dataset is scarce and unavailable. Building them is tedious, time-consuming, and expensive. They depend on domains and languages. This is especially a big challenge for low-resource languages. In order to save time, money, and human resources, many research teams study many solutions how to still obtain high performance under limited training data. Data augmentation is one of the solutions. Data augmentation is a technique to enrich the training data by generating new data without user intervention. Data augmentation techniques first have been used in image classification to enrich the image training data by rotating, scaling, translating the images. They are rarely equipped in natural language processing for semi-supervised learning approach and deep learning models. The rabbit hole of web technology has created a huge amount of data on the internet. Mining them helps to resolve many problems, especially in machine learning, especially for low-resource languages. Our main contribution builds a retraining model for Vietnamese reviews by collecting reviews from e-commerce websites. And this paper evaluates the importances and impacts of the contextual substitution to enhance the training data applied for sentiment analysis problems. Session 2 Related work. There are many approaches proposed to generate training data, such as lexicon-based techniques, generative text by translation, syntactic transformation, word or sentence embedding method. For lexicon-based techniques includes synonym replacement. Take a random word from the original text and replace by synonym words based on thesaurus. Lexicon deletion removes a random word in the text. Synonym insertions. Take a random word not be in a stop word and get one of its synonym words, insert a random position in the text. Swapping, swap randomly two words in the text. Or words or sentence were suffering in the sentence or sentence suffering in a paragraph of text. Although the technique may generate meaningless sentences, but the techniques are simple, easy to implement, short languages, and actually improve the accuracy of predictive model in practice. For back translation. Back translation leverages the translators to generate new samples. Firstly, the text is translated from its original language into the destination language. Then, it will be back translated into the original language to obtain new data. The translated text has usually never been exactly the same as the original text. This approach is easy to understand and implement, still retain the meaning of the original text, and achieve good performance. But the quickest point of this method is to unique and effective translators. For syntactic transformation, generate dependency tree of original text then using some rules such as from active voice to passive voice transforms into the augmented text. For embedding-based substitution, Computation proposed the contextual data augmentation for the label synthesis. This offers a list of substitute words reduced by a bidirectional language model according to the context. Section 3. Our approach. We use the contextual substitution approach to generate new training data and evaluate the impact of choosing the words in text replaced by the contextual words. As you know, word embedding is an useful tool for machine learning and deep learning to convert text into vectors. In word embedding, the words at the same context will be near each other in vector space. Ideally, the vector of words have the same meanings, being also near each other. We can utilize this point to generate new samples by replacing the contextual words of a word in text. Fortunately, the enormous resources on the internet and outstanding developments of pre-trained models provide many available word embedding models based on word-to-vector or BERT. In this paper, we use word-to-vector to build a retrained model for the Vietnamese reviews by collecting reviews from e-commerce websites, perform various experiments to evaluate the importances and impact of the contextual substitution with neural network models. The third approach, we replace end words in the text randomly with the contextual words for new sample. However, contextual substitution randomly considered a black box approach, so opposite words may be also near each other in vector space. So it may affect the performance of some problems such as sentiment analysis. So the second approach, we use TF-IDF score to choose the replacing words instead of random choice. The words have slow TF-IDF score, usually uninformative, so replacing them usually does not affect the meaning of the original text. The next one, we incorporate two methods with the mixed embedding to generate new synthetic sample before feeding to the output layer in neural network models. Data augmentation with measure has first proposed by Lisan for image classification. This technique generates synthetic sample through linear interpolating of a pair of input images and their corresponding labels. You can see the formulas on the slide, where Eai Ictcc are the input vector, Yai Yz are the output labels. Lambda is the measure ratio having the value between 0 and 1. Our work inject the measure layer to obtain the synthetic sample before feeding to the output layer to predict the result. You can see this is the augmented training sample after applying the contextual substitution input to the neural network models. Before feeding to the output layer, we inject the measure layer for new synthetic samples. The experiments. For experiments, we use 4 datasets, where dataset 1, 3, 4 have 2 polarities, and dataset 2 has 3 polarities. Firstly, we apply the reprocessing technique for the dataset to remove some noise information, normalize and clean the text, such as lowercasing, emoji substitution, negation handling. We use 100 samples for training of each polarity and generate 1,000 new sample modes for each polarity. Furthermore, we build a retraining model which works better by collecting about 100,000 reviews from Vietnamese e-commerce websites. Neural network model has input layer, output layer, and two hidden layers. Existing units, the hidden layers use reload activation. The output layer uses sigma activation function, loss function, binary cross entropy, training with 20 epochs in media batches of 512 samples. This is we conduct 5 experiments. This table shows the means of the accuracy with standard deviation in 10 runs. The first column is conducted with the original test data, the baseline result, our baseline result. The second column generates new training data with random substitution by the contextual words. The third column generates new training data based on TF-IDF score. The fourth and fifth column incorporate two methods with mixed embedding. The figure shows the visualization of the result, where the x-axis is the experimental dataset. The y-axis is the mean of the accuracy over 10 runs. Each dataset runs on our experiments. The accuracy of the approach overcomes the baseline. The first column of each dataset is the baseline result. The TF-IDF-based substitution is greater than random-based substitution for dataset 3 and dataset 4. So selecting good words to replace the contextual words affects the quality of the augmented data. However, other cases are in the opposite for dataset 1 and dataset 2. The reason why, as earlier mentioned, work embedding is a black box approach, so the opposite works may be near each other in embedding. In social reviews, some important words are also low TF-IDF score. For example, high long, these works, which is commonly used in positive reviews, hello TF-IDF score. So, replacing them sometimes change the meaning of the text. Finally, the accuracy of the contextual substitution combined with the mixed embedding improve the performance of datasets compared with only performing the contextual substitution separately. Although the results of the combination are more stable with the very minimum deviation for all datasets. The final session conclusions. This paper collects a set of reviews from well-known e-commerce websites and builds a retraining model for the contextual words. We conduct the various experiments to evaluate the effectiveness of the contextual substitution in generating new samples in Vietnamese. The experimental results show that selecting the word in the original text and selecting a word in the contextual words for substitution affects the quality of the augmented data and the performance of predictive models. The experiments show promising results. This utilizes the abundance of the internet data and can apply for lost languages and saves cost and build the tailored awareness of the specific languages for the substitution approach. In the future, we enhance more data to boost better quality and generalization of retraining models and investigate novel methods to augment data, especially applying to Vietnamese. Thank you for your watching.
Welcome to our presentation. Let me introduce myself. My name is Qua Dang Dang Lu, a member of the Hospital Information System team in Vietnam Posts and Telecommunications Group, Tin Giang, Vietnam. Today I am here to present to you the topic patient classification based on symptoms using machine learning algorithms supporting hospital admission. The content of my presentation is in 6 parts. Firstly, I will talk about the introduction and motivation of this research. Secondly, I would like to have an overview to motivate related work. Thirdly, we describe the data for the experiment. In the next, introduce and illustrate our proposed method. Part 4 Introduce and illustrate our proposed method, while Part 5 reveals and evaluate the experimental results. Finally, the conclusions are reported in Part 6. Receiving and flowing patients into hospital clinics is a rather complicated matter. Overcrowding of patients waiting for medical examinations at hospitals in Vietnam has become alarming. In many papers, the authors stated that long waiting times became an important part of the perception of a general. For most hospitals in Vietnam, patients have to wait for a long time for hospital admission procedures. Although some solutions have been proposed to reduce and pre-arrange appointments with the doctors, almost all people still tend to crowd at the hospital for their healthcare services. In hospitals, the idea of designing arrangements and suggestions for flowing patients to the medical clinics accurately and quickly helps to increase work efficiency. Usually, in the morning in most hospitals, patients wait for reservations, especially in outpatient departments, accident and emergency departments, receiving and flowing patients into appropriate hospital clinics to help patients avoid fatigue and minimize conflicts between patients and medical staff. Receiving patients and flowing patients to clinics in the hospital to diagnose diseases corresponding to signs and clinical symptoms helps avoid wasting time on medical examination and treatment of doctors and patients. Because if the patient's flow is not accurate, the doctor must operate to transfer the patient's room, which is both laborious and time-consuming for the doctor and the patient. In the Fourth Industrial Revolution, we received more and more information sources in statistical data, especially in the medical field. The information source comes from medical facilities that directly perform receiving and examining and treating patients. Therefore, discovering hidden knowledge from the medical data warehouse is necessary for managing and completing this vast source of medical information. The acquired knowledge can be a classification model or data clustering commonly used in models, including automatic labeling of data and data analysis to identify anomalous data. In recent years, the development of machine learning in healthcare has made significant progress. As a result, machine learning applications have a wide application area, especially supporting and comprehensive care of people's health. For example, numerous applications are related to personal health monitoring to reduce disease risk, early detection of modern diseases such as cancer, cardiovascular disease, help reduce costs and prolong life, help patients comply with medication, monitor disease progression. Machine learning is applied in critical areas of medicine, in clinical decisions, electronic health records, diagnostics, medical robots, personalized medicine, medical examination, and treatment management. The progressive application of machine learning in healthcare can improve access to healthcare and the quality of healthcare. In this work, to develop an automatic patient classification based on symptoms in the text to speed up admission at hospitals, we propose to use the bag of words model primarily as a tool for generating word features from the text. After converting the text into bag of words, we will use term frequency inverse document frequency to determine the importance of a word in the text to extract the features which are input for machine learning algorithms to perform the classification tasks. Then, we use machine learning algorithms that are leveraged to perform practical disease classification tasks. After obtaining the learning from models, we have deployed an explanation model technique, local interpretable model agnostic explanations, to extract insights in data, including keywords for disease diagnosis. The experiments are evaluated on the dataset, including 33,024 health record samples at the Health Center of My Tho City Tien Giang, Vietnam, with 10 common diseases in Vietnam. The bag of words model is a simplifying representation used in natural language processing and information retrieval. In this model, a text, such as a sentence or a document, is represented as the bag, multiset, of its words, disregarding grammar and even word order but keeping multiplicity. The bag of words model has also been used for computer vision. The bag of words model is commonly used in methods of document classification where the frequency of occurrence of each word is used as a feature for training a classifier. The following models a text document using bag of words. Here are 3 simple text documents. Paragraph 1, the weather is nice. Paragraph 2, I will go hanging out with my friend. Paragraph 3, my friend also likes that too. Based on these 3 text documents, a library is constructed as follows for each document. With paragraph 1, the weather is nice. We can see each word in the paragraph above mapping to the library obtained in the previous slide. Each key is the word, and each value is the number of occurrences of that word in the given text document. In practice, the bag of words model is mainly used as a tool of feature generation. After transforming the text into a bag of words, we can calculate various measures to characterize the text. The most common type of characteristics, or features calculated from the bag of words model is term frequency, namely, the number of times a term appears in the text. In information retrieval, TF, IDF short for term frequency, inverse document frequency, is a numerical statistic that is intended to reflect how important a word is to a document in a collection or corpus. It is often used as a weighting factor in searches of information retrieval, text mining, and user modeling. The TF, IDF value increases proportionally to the number of times a word appears in the document and is offset by the number of documents in the corpus that contain the word, which helps to adjust for the fact that some words appear more frequently in general. TF, IDF is one of the most popular term weighting schemes today. A survey conducted in 2015 showed that 83% of text-based recommender systems in digital libraries use TF, IDF. Variations of the TF, IDF weighting scheme are often used by search engines as a central tool in scoring and ranking a document's relevance given a user query. TF, IDF can be successfully used for stopwords filtering in various subject fields, including text summarization and classification. One of the simplest ranking functions is computed by summing the TF, IDF for each query term. Many more sophisticated ranking functions are variants of this simple model. TF-IDF denotes term frequency, inverse document frequency, while TF-IDF is calculated as. In our research, we use 5 machine learning algorithms such as random forests are frequently used in many computer vision and machine learning applications. The random forest technique is a regression tree technique which uses bootstrap aggregation and randomization of predictors to achieve a high degree of predictive accuracy. Support vector machines are a set of related supervised learning algorithms developed by Vladimir Vapnik in the mid-90s for classification and regression. SVMs is a very attractive and useful tool for classification and regression. Decision tree is a tree whose internal nodes can be taken as tests on input data patterns, and whose leaf nodes can be taken as categories of these patterns. This is one of the algorithms in supervised machine learning which is used in predictive analysis and regression in the most subtle way. Decision trees are sometimes the best algorithm to do the task while considering the time and space complexity. Multinomial naive Bayes method, which is widely used in word frequency analysis, is used to generate several weak classifiers. logistic regression continues to be one of the most widely used methods in data mining in general and binary data classification in particular. This research examined the patient admission dataset, with 233,024 samples containing the information, age, gender, clinical symptoms of the patient to propose building a machine learning model, which supports the implementation of automatic classification diseases and decision to flow patients to hospital clinics, table and slide. Data were collected from March 2016 to March 2021 from the Medical Center of My Tho City Tien Trong, Vietnam, from Admissions and Discharge Office, Outpatient Department, Accident and Emergency Department, and related reports. The data is manually and semi-automatically retrieved patient information, QR code and health insurance card. The dataset includes the following fields: age, patient's age; sex, patient's gender, 1 male, 0 female; clinical symptoms noted by the medical staff who receive the patient when the patient declares at the admissions and discharge office. The patient's clinical symptom information may contain information about the patient's physical fitness, abnormal vital signs, symptoms and manifestations before and during hospital arrival. ID_diseases. This is information about a patient's type disease that is recognized after being examined, treated by a doctor and identified with the patient's ICD-10 disease code, a group of diseases that includes many diseases, a type disease that includes many groups of diseases. In the table of data, there are 10 common types of diseases in Vietnam. Architecture of system proposed for classifying the type disease. Beginning with medical data, we prepare data preparation. Then we divide it into a training set and a test set. In the training set, we perform feature engineering using a bag of words model and have a dictionary words vector. Then, we transform with word vectorization and TF-IDF and prepare input data for machine learning algorithms. In the test set, we transform with word vectorization and TF-IDF, dictionary word vector above, and do model evaluation with performance measures, accuracy, precision, recall, F1 score, Gini coefficient. We compare performance among considered classifiers. As observed, logistic regression reveals the best result, while multinomial naive Bayes exhibits the worst one. In the above analysis, using the logistic regression algorithm to achieve the best results with measures accuracy equals 79.1%, precision equals 79.9%, recall equals 79.1%, F1 equals 79.5%, Gini equals 92.1% and time 159 seconds. Multinomial naive Bayes algorithm achieved the lowest results with the measures accuracy equals 72.7%, precision equals 75.1%, recall equals 72.7%, F1 equals 72.5%, Gini equals 88.7% and time 246 seconds. The algorithm's SVM random forest gives results with a reasonably high accuracy measure of more than 78%. The algorithm's decision tree gives results with the measure's accuracy equals 74%. We have some interesting analyses from the dataset when using the LIME technique to analyze important words affecting type disease classification performed by logistic regression shown in figures at the slide. Use LIME to explain the prediction of logistic regression and display the word symptoms description that can be key word to describe the disease. We extract the essential features in the above classification model, Important information that dramatically affects the patient classification process is shown in the patient's blood pressure. Confusion matrix of prediction results with logistic regression. We reveal the confusion matrix in Fig at slide using logistic regression, where we obtain the best results. Because we have an imbalanced dataset, the classes are not represented equally. The model is perfect for classes 3 and 5 with more than 90% accuracy, and good for classes 2, 7, 8, 9 with more than 80% accuracy, not good for class 1 with 68% accuracy. We have presented a method to solve automatic patient input flowing. Our research is based on a combination of the method of representing text by the bag of words model and data classification algorithms. The bag of words model is built simply, quickly, to represent the text as a vector of occurrence frequency of words in the text with the number of dimensions is very large. Incorporating other patient-specific information allows efficient classification of this data set. The proposed approach provides an automated way of patient flow in the hospital to improve healthcare in the future. Thanks you so much for your attention.
Hello, my name is Bùi Vũ Hoàng. I'm from the Ho Chi Minh City University of Technology in Vietnam. Today I will present my team research. It's implementation of motion control for an Omni robot using trajectory linearization control. And it's my first time I have a present in a conference. And my presentation has five parts, five sections. The first is introduction. The second is mathematical design. The third is controller design. And the next is result and of study. And finally is conclusion. And this study introduced the design and modeling of the nonlinear control based on the Omni robot wheel for the mobile robot. Um, in the introduction, the main object of this research is an Omni robot directional mobile, and in my paper, I use an Omni robot has three orthogonal wheels that are fixed at each vertex of the even triangle controller, and this is a real Omni robot, and this is a real Omni robot, and this is a model of the Omni robot. The Omni robot controlled by the three DC servo motor, and the main MCU microcontrol unit. Also, an embedded computer to calculate the inverse kinematic and receive directive from the main PC to the LAN. And besides, the position of object is determined by a rough camera. This is the hardware of the mobile robot, Omni robot. It's a motor and wheel and MCU, a particle and camera. And in the previous research, have three problems. The first is ideal servo motor is used without error. In the real condition, the dynamical constraint of the servo motor could significantly affect on the robot motion. And though we have a modeling for the DC motor, the second, the feedback gain of the controller had to be turned to the achieve system stability for trajectory is solved by fuzzy and adaptive method. Because in a dynamic environment, it's hard to predetermine the trajectory and adjust feedback gain. And the third problem is friction. Friction and slip is also ignored, despite being mentioned as some research. And in my paper, in my research, we have a three part, three idea. The first is trajectory linearization control DLC scheme on the omnidirectional mobile robot, which combine the linear inverse kinematic duty of the linear time varying agent tractor, the nonlinear tracking and decoupling controlled by the trajectory linearization can be handled at a perfect gain scheduling control, and thus design as very point in the trajectory reboost. The third is reboost stability and excellent performance along the trajectory without interpolation of the control gain. And the second section is mathematical model. And the first initial we have a two assumption in our because to design a controller for a robot, the description of the robot motion are essential to be indicated with some assumption to below. The first assumption is since the electrical time constant of the motor is too small. The wheel roll on the flat without slip, and the friction force is simplified to be represented by a viscous damping coefficient called assumption 2 E. The model dynamic will be compensated by the feedback control, which is based on the simplified model in the next section. And the first is coordinate of the symbol. This is the coordinate of the omnirobot, with L is the distance between the driving motor and COG. COG is the center of the gravity of the robot. M is the weight of the robot. I is the moment inertia of the robot. R is the radius of the driving wheel. N is gear ratio. And the the work coordinate system, we assume that the world coordinate system is fixed on the ground and the local coordinate system is fixed on the COG. And below is a velocity in the world coordinate system, and the angular velocity of the motor is WM. And location of the robot is expressed in the world coordinate as following. And we have a position of the robot, and the robot velocity consisting of linear velocity and angular velocity. Is in the coordinate the world. The fixed coordinate. Some system parameter will illustrated in the local coordinate with attached to the body of robot. R is the Rm is a position vector of the position of the robot COG. Theta is the phi is the rotation of the rotational angle between the xw and xm. Vm is the velocity of linear include velocity, linear velocity, and angular velocity. F is a traction force of the wheel. Here is the relationship of the rotational velocity of the motor and their velocity in their velocity with metric transformation being from the local coordinate to the world coordinate. The kinematic equation of the system can be derived. Here is a robot dynamic with the traction force. We get the dynamic equation of the system in the body frame in order to the supply voltage to the motor, with U is we call the voltage to the motor or the input signal. We have a relation below, and after we model we model mobile robot, and the next we will design the controller. Here is the structure of the control using DLC for the Omni robot, and we have a two controller. The first is outer loop controller, and secondly is the inner loop controller. The the first outer loop controller is we define the tracking command for the inner loop is given by outer loop. Sorry, it's outer loop, and by linearization of the function linearization of the function about the equivalent point is given by we have the final equation is EE and EFI. With the EE and EFI is a tracking error of the real position and reference position, and use the PI controller to decide the stabilizer of the system performance. And to find the KB and KI, and based on the design of response and tracking error, we choose a suitable pole and design the coefficient of the design close-up characteristic polynomial. We get the KB1 and KI1 and two function. And after we design outer loop, the next is the inner loop. The inner loop is the tracking command for the inner loop is we using the U1, U2, and U3. It is inner loop control the motor, more DC motor, and it's related to the use is voltage input signal, and output is the velocity of the motor. We define the AMVX, AMVE, and AMVV is a tracking error of the velocity. Mm, Similarity with the outer loop, we we find the KA1 and KI2 and KP2 like this, and the the fourth section is result study. We have two result study. The the first is uh, uh, control control robot to point, and initial position of the robot is 000, and robot will move and stop position reference position. In example, it show how like this is the performance of the tracking error, performance of the working of robot on the H-axis, E-axis, and rotational axis. The second example, we design the robot tracking the circular trajectory is in result with speed from the O point O five radius to 1 radius per second. And finally, section E, conclusion. And with the three conclusions for this paper. The first is equation of the motion for an omni-robot via dynamics, kinematic, and motor actuator to simulate the hardware platform. And two, the second, a linear controller were implemented to design by TLC method. And the third, the robot can track trajectory with relative accuracy and the settling time is reasonable. And my presentation is and it finished, and thanks for watching.
Ladies and gentlemen, let me thank you all for being here today. My name is Nguyễn Quốc Việt. In our presentation, we would like to talk about our paper with the title Adaptive Deep Learning Technique to Predict Student Graduation Result. We divide our presentation into 5 main parts: introduction, background and related works, the robot methods, result analysis and conclusion and future work. Firstly, we will be looking at introduction. Analyzing educational data techniques helps educational institutions predict the final graduation result of students based on the average score in the first semester of the course. The robust method is based on the average academic point data of the 6 main semester out of a total of 8 main semesters of students to predict their graduation result with the accuracy of about 90.53%. Ho Chi Minh City University of Education has the mission of training, fostering teachers, and organizing applied research in education and other science to fulfill the needs of high-quality teacher training of advanced research for the cause of development in education, society, and economy of the province in southern Vietnam and the whole country. Educational data mining is also an area that many scientists have been researching using educational data in universities and colleges to collect, to analyze, predict, and support decision making has become one of the most important contributions to improve the quality of education in universities and colleges. One of the essential factors that directly affect the graduation result of students is the average score of the course. We use the data of the average academic points from the 6 main semesters to predict their graduation result. Subsequently, we will go on to background and related work. Educational data mining is a field of data mining. Early prediction of student results can help administrators make the necessary decision at the right time and create the right training plan to improve student academic success rates. According to previous research, student academic success is defined by factors such as academic achievement, demographic, satisfaction, competencies, acquisition of skill, attainment of learning objectives during their academic careers. There are many approaches to predict student learning outcome, in which the classification model and the regression model are the most used. The algorithms used in the classification model are decision tree, Bayesian, artificial neural networks, rule cleaners, ensemble learning, k-nearest neighbor. For forecasting student results, recent studies have used techniques such as decision tree, deep learning, neural networks, Navy-based support vector machines. In addition, some other models are also used for student result prediction, like generalized linear model. Data mining techniques are used to predict student performance in the first or the second year in the university. So, deep learning is also a widely and used technique and remains an important role in predicting student final GPA. Thirdly, we will talk about the robot method. As you can see on slide, our robot model has five steps. Data collection. The data provided by our university, which is blurred, includes data of graduates in 2018, 2019, and 2020 for training. Besides that, data of students who are graduated in 2021 are used to deploy the train model. Our university has approximately 2,000 graduates every year. Therefore, predicting graduation results will significantly help students while studying at the university. Our data has 6,064 students, with their data property as student ID, gender, student GPA in semester 1, 2, 3, 4, 5, 6, and final graduation result. In data reprocessing, the provided data is stored in many individual datasets. It is heterogeneous in structure and properties. So we have processed the data by selecting the necessary attributes for this study and shelving them to a single dataset so that training model can be deployed. In predict a student graduation result model, according to the related works which presented in the previous section, the neural networks method has many advantages in predicting student graduation. Therefore, we choose the method to solve this problem using neural networks. Evaluating model. We will evaluating the performance of the model and again the other models such as decision tree and random forest. Deployment model. After conducting experiments with the data of graduates in 2018, 2019, 2020, we will deploy the Apple model for predicting graduation rate for graduates in 2021. Next, we will start off by showing you photo of the prediction student graduation result model. The input layer includes 7 attributes as gender, student GPA in semester 1, 2, 3, 4, 5, 6, and final graduation label. With the hidden layer 1 and layer 2, every layer has 50 nodes. The output layer is divided into 4 classifiers: average, good, very good, excellent, because the students do not graduate if their GPA is below average. Next, there is the parameter of robust model. Loss function is multi-class cross-entropy. Optimization method is stochastic gradient descent. Learning rate is 0.005. Number of hidden layer 2. Neuron is layer 50. Each box equal 300. Epsilon equal 10 to the minus 6 power. The beta 1 is 0.9. Beta 2 is 0.999. Parameter for hidden layer 1 and hidden layer 2 activation function is rectified linear unit. Output layer activation function is softmax. The model will be fixed for 300 training each box and learning rate 0.005. Dataset A includes 4,648 students who graduated in 2018, 2019, and 2020. Every data in Dataset A has 9 attributes. Dataset B includes 1,416 students will graduate in 2021. Every data in Dataset B has 8 attributes. After that, we will go on to result analysis. The robot methods have 1,683 correct classified. The decision tree methods have 1,563 correct classified. The random forest methods have 1,543 correct classified. As you can see, the accuracy of tree methods. The accuracy of the robot methods is 90.53%, while the accuracy of decision tree and random forest methods are 84.08% and 83%. So the results of the robot methods are better than other methods. In dataset B, predict the learning outcome for 1,416 students who are preparing to graduate in 2021. As you can see the number of true and false predictions in table sheet. This is accuracy and error of the robot method with the other method in dataset B. The accuracy among the model is not significantly different. The highest accuracy belongs to robust methods at a rate of 90.04%, while the accuracy of decision tree method and random forest method are 84.32% and 82.7%. Finally, we will go on to conclusion and future work. The robust methods used in this study give pretty good output in terms of performance. Along with training and testing the models, the research has also deployed models to predict the result for students graduating in 2021 with the high prediction accuracy. In the future work, besides using the average score and the grade classification, we need to use more data from the result of each subject to increase the result predicted. This is our references. Today, we presented about adaptive deep learning technique to predict student graduation result. Well, this brings me to the end of our presentation. Thank you very much for your attention. We hope the best will always come to on you. Hope you always have good health to enjoy the good luck. Thanks for your watching. Thank you very much.
Hello everyone, it's an honor to be here at the Ictcc 2021 conference. The topic of our paper is an approach for multiple choice question answering system. The outline of my talk as follows. The first part, we will introduce and present the advantage of the automatic system. The second part, we will briefly present some studies that are related to our work. The third part presents methods that are used for the automatic English multiple choice test system. And the last part presents the experimental results and conclusions in our future direction of system development. Well, let's move on to the first part of this topic. Multiple choice questions plays a major role in educational assessment. Using the automatic system not only reduces the burden of human experts in teaching and evaluating the student, but also is useful for self-study. We developed the multiple choice question system for the forms of incomplete question in English exam in any subjects such as grammar, nouns, pronouns, vocabularies, verb tense based on our training corpus, which is collected from well-known websites. Our main contribution has performed the existing methods for multiple choice questions problems such as language model like Unigram, Bigram, and max language model, proposed and evaluated an approach as an example of both methods to improve the accuracy of multiple choice question problems. The next part is related work. Question answering systems have been concerned and have many proposals for it, such as Hữu Thành Dương and Bảo Quốc Ngộ, using language model for question answering system in legal documents. It is presented in a Vietnamese question answering system in Vietnam's legal documents. Hữu Thành Dương and Vinh Trương Hoàng combining of machine learning classifiers in new classification. It is presented in question answering based on example classifier for university enrollment advising. Yaspahan Sama and Sahil Gupta applied the deep learning approaches for question answering system. It is presented in deep learning approaches for question answering system. When how you using transfer learning with Albert to build question answering system in technical domains. It is presented in a technical question answering system with transfer learning. As a form of question answering system, multiple choice question has emerged and attracted many research teams to resolve the multiple choice questions in recent years. Eai Ictcc proposed to use CNN model to answer the multiple choice questions in particular domains. The accuracies are better than the baseline result as LSTM model in two datasets as textbook question answering TQA and SciQ datasets. It is presented in CNN for text-based multiple choice question answering. Kavita Mohoka proposed an example of model approach, including LSTM, hybrid LSTM, CNN, and multi-layer perception model to predict the correct answer. LSTM and hybrid LSTM CNN model are firstly trained parallelly. Then the multi-layer perception model predicts the correct answers. This approach obtains higher accuracies than using the models separately. It is presented in multiple choice question answer system using example deep neural network. Radha Chitta and Alexander K. Hudek developed the question answering system for multiple choice questions in legal contract. They have extracted the relevant text contract and used a multi-class classifier to choose the correct answers based on the extracted text. It is presented in a reliable and accurate multiple choice question answering system for dual diligence. Jay Devlin at Google API Language published bidirectional encoder representation from transformer. This applies the bidirectional training of transformer instead of only looking at the single directional training like the previous effort. In this paper, they also introduced a novel technique named Masked Language Model. Masked Language Model is an important model of BERT. The next part is methodology. We use a statistical approach including language model like unigram and bigram and masked language model. These models are conducted separately to evaluate the effectiveness. Then we propose an example of two models to improve the performance of multiple choice question problems. The experiment presents this approach achieves better accuracy significantly than applying the model separately. Language model is a statistical approach learning the probability distribution over a sequence of words based on the existing corpus. This model is widely used in information retrieval. This refers to an effective solution to predict the correct choice of the multiple choice question in incomplete form based on its probability distribution. The main purpose of language model is to calculate probability distribution over a sequence of words based on the Bayes formula. Language model need to use a large amount of memory to store the result of the string. This would be impossible if the length of the string is a paragraph or even more, because the length of a natural long text is infinite. The n-gram model will solve this problem by calculating the probability of the sequences with lower memory. The accurate probability of a word will depend on n consecutive words preceding it, not on the entire sequence. Thus, we have the probability of words calculated as follows. For n equal 1 called unigram, which is the simplest model in n-gram. It evaluates the probability of each word in a sentence independently as below formula. For n equal 2 called bigram, this would consider the probability of occurrence of two consecutive words in a sentence according to the formula. Masked language model combine transformer encoder and masked token can predict a missing token in a sentence. The output of masked language model is the word embedding of the corresponding token, which fit to a simple submask classifier to get the final prediction. The missing token is represented by masked symbol in a sentence, and masked language model predict the suitable token for replacement, but can predict through the context of word in its right and left direction. This considers the context of the whole sentence, so this can predict well the missing token. Masked language model use bidirectional context words of the hidden words and consider the context of the whole sentences, so this is a good approach for incomplete form. However, for multiple choice questions, the correct answer only limit in specific choices. As a result, masked language model cannot sometimes give the final answer since the predicted words do not match any choices. Otherwise, n-gram model always obtain the final answer, but they only consider the previous words of the hidden word. Our proposals give the combination of n-gram model and masked language model. In order to determine the correct answers, we use a formula based on a linear equation. So let's see the experiments and results. First, the dataset. We have extracted 207,319 documents, like magazine, article, from the well-known website in English and prepare 502 multiple-choice questions with answers for testing to evaluate our approach. Unigram gives the answer and obtains 29.48%. Bgram gives the answer and obtains 57.37%. The multiple choice questions demand the formal structure and grammar, so the order of words is essential in text. The Unigram does not concern this, leading to this model obtain a low accuracy in this problem. The Bgram model calculates the probability of a word based on the context of its previous word. It improves accuracy significantly compared to the Unigram model. For masked language model, the selected answer is suggested by masked language model and matches one of the choices of the questions. Its accuracy is 44.02%. This model predicts the hidden word based on its bidirectional words. However, there are many cases in which it is impossible to produce the results, since some suggested words of masked language model not matching any choices of the question. The combination of Unigram and masked language model obtained 82.66% accuracy, and the combination of Bgram and masked language model accuracy is 84.46%. As you can see, the combination of Unigram and masked language model obtained 82.66% accuracy with alpha between 0.1 and 0.99. The highest result, which is the combination of Bgram and masked language model, is 84.46% accuracy with alpha as 0.99. In order to select a good alpha value, we perform many experiments with various alpha values. So, okay, that's the end of my presentation. Thank you for your watching.
Among the outstanding contribution to ICTCC 2021, the technical program committee decided to choose the following two papers as best paper to win the best paper awards. The first one with the title of Forecast of the VN30 index by day using a variable dimension regression method based on kernel tricks written by author Rowan and Wivenhai. The second one with the title of Adaptive Deep Learning Technique to Predict Variation Result, written by authors Nguyễn Bình, Nguyễn Quốc Việt, and Võ Phạm Trí Thiện. Congratulations to author. Dear participants, the ICTCC 2021 ended successfully and smoothly after 1 day of intensive and inspiring work. On behalf of the organizing committee, we would like to express our sincere gratitude for your contribution. Special thanks go to the presenter, keynote speaker, chair, and other discussants who have contributed a great deal to the success of the events. We hope that all the participants have found some valuable insight and begun building an active network of those deeply interested in the field of natures of computation and communication. Once again, thank you for your outstanding contribution. We look forward to working with you on future events. Best wishes.